Okay, so welcome to paper 2 higher. Now obviously I mentioned in paper 1, so if you haven't already seen it, I'd recommend checking that paper out first, that obviously how to use this video is to make sure that you've downloaded the paper. So if you go into the description, you can download the paper right at the top there, or you may just want to watch the video, in which case just know it's there and you can download it at any point. Throughout the video as well, you'll see that below in the description, you've got the links to all of the papers here that are going to be linked to this one. You've got some links to download some free resources from the website, and you also have down below all the timestamps with all the topic names and full lessons linked to any of those. Now this is obviously the paper 2 paper, so I'm just going to show you some of the topics that are going to appear on here. So again, this is the checklist that you can download from the website. The link is in the description. Now if you look, the red ticks are the ones that we did in paper 1 and the purple ticks are the ones that are appearing in this one. So over the course of 2 papers we have managed to cover off quite a lot of the topics. There are still some left for paper 3, but as you can see some of the pretty tricky ones are included in this one. We've got some calculating bounds, we've got perpendicular line equations, we've got algebraic proof and graph transformations, inverse and composite functions, and as we go on to the next page we've got some cumulative frequency graphs, we've got vectors, geometric proof, and all that sort of lovely stuff. So there we go, this you can download in the description, but there you go, just to give you some rationale as to some of the topics that are behind the paper that we are doing. But without further ado, let's get started. Okay, so getting started with higher paper 2. Now don't forget, if you obviously have the booklet, you can scan the QR code on the front, it'll bring you back to this video at any time. So getting started with the questions. Question 1, we've got to work out the reciprocal of 0.125. Now the reciprocal of a number just means we need to flip it over when it's written as a fraction. At the moment it's written as a decimal though, so not forgetting that throughout this paper we're obviously using our calculator. So if we type in 0.125 on the calculator, press equals, that comes up as 1 over 8. So at the moment this is the fraction 1 over 8. If we want to do the reciprocal of that, we just need to flip it over. So that becomes 8 over 1. And of course, when we are doing the reciprocal, if there was a different number on the top, then we would have to leave that number on the bottom. But of course, this is a 1 on the bottom, so we can just write our answer as 8. For part B, we have got some powers, writing as a power of 3, but we've got some pretty large powers there. Now the numbers shouldn't put you off, particularly when we have a calculator for this. We know that when we are multiplying, we need to add the powers. So we've got 140 and 59. Now if we add those together, that gives us 3 to the power of 199. That's our numerator. On the bottom we've got 3 to the power of 49. We know that when we're dividing, you subtract the powers. So we have 199, take away 49, that leaves us with 3 to the power of 150. It says to leave our answer as a power of 3, so we would just write 3 to the power of 150, and there we go, written as a power of 3. For part C, we have powers in brackets. When we've got powers in brackets, you multiply those powers. So the y and the 3 are going to get multiplied. That's going to make the number 60. So we could write that as an equation. You could write 3y is equal to 60, and then divide both sides by 3, you get y equals 20. Of course you might just spot that that's 20, you might not need to write the equation, but there we go, we can write it like that anyway. Question 2, we have a Venn diagram. So it says here we're using all the numbers from 1 to 13. A is the multiples of 3 and B is the even numbers. Complete the Venn diagram. So we want to label this up A and B. After that, from the list I would write all the multiples of 3. So we have 3, 6, 9 and 12. The even numbers in that list, we have 2, 4, 6, 8, 10 and again 12. Now we want to find what numbers are in the intersection. So you can see in both those lists we have a 6 and in both those lists we have a 12. So 6 and 12 go in the intersection. Remaining in A we have 3 and 9, and in B we have 2, 4, 8 and 10. Now if we go to our main list and start crossing those off, we used 2 and 3, 4, 6, we used 8, 9, 10, and we used 12. That was one of our even multiples of 3. Now the remaining numbers in that list just need to go on the outside. So we've got 1, 5, 7, 11 and 13. And just double check, make sure that you have put every number in that list, and make sure that you haven't got any doubles anywhere. You've not put, say, the 2 in 2 different sections of the Venn diagram. So there we go, happy with that. And there is a Venn diagram for question 2. Question 3. A supplier sells packets of sweets to shop owners. On Monday, 3 shop owners buy sweets from the supplier. Each shop owner buys small packets, medium packets and large packets of sweets. We've then got 3 bits of information. We have Shania that's buying 400 packs of sweets, and we've got some percentages about those. Stacey buys 500 packets of sweets, and we have some fractions about hers. And then Ruxton buys 150 small packets of sweets, and then we have a ratio of the number of small to medium being 3 to 4. Work out the total number of medium packets of sweets. So, if we go back to Shania and work out her percentage, a few different ways that you could do this. If we add together 32% and 40%, that in total right there is 72%. 100 take away that 72 means that 28% must be medium. So 28% are medium. If we want to work out 28% of 400, then we can first get 1% by dividing by 100. Obviously you're doing this on the calculator as well, so that's 4. And then 4 multiplied by the 28%. So 4 times 28 gives us 112. So we have 112 medium packets that Shania buys. If we look at Stacey, Stacey has 3/10 that are small and 1/10 that's large. In total, that's 4/10. So that means medium packets would be 6/10. So again, if we work out 1/10, which is just dividing by 10 on your calculator, that gives you 50. For 6/10 that are going to be medium, times that by 6, you get 300. So Stacey buys 300 medium packets of sweets. Over to Ruxton, we have small to medium that's in the ratio 3 to 4. And it tells us that he buys 150 small packets. So this 3 is turning into 150. And how do we do that? Well, we'd multiply both sides of the ratio by 50. You can work that out by doing 150 divided by 3. So we need to do the same to the 4, times that by 50 as well. And that gives us 200 medium packets of sweets. Again, don't forget, it does say you must show all your working. So even in this final step, where we need to add together the 112, the 300 and the 200, I'm just going to show that working out. So 112 plus 300 plus the 200. Obviously you can add those together on a calculator, so let's do that. So that's 112 plus 200 plus 300, and that is 612 medium packets of sweets. So our final answer for this question, 612, and that's the amount of medium packets of sweets that are bought. Okay, on to question 4. So we've got some solving an inequality to start with, and then we've got a number line for part B. So in solving an inequality, we'll solve it just like an equation. We're going to get rid of the smallest value of n in this case on both sides. So the smaller value is the 11n, so we want to take away 11n from both sides. When we do that, we're left with 3n that's going to be greater than 6. That leaves us with a nice solution as well, because when we divide by 3, we get n is greater than 6 divided by 3, which is 2. So n is greater than 2 as our final answer. For drawing on the inequality, drawing this inequality on the number line, just being careful with this one, because you do have x plus 3 in the middle, and we want it just to be x in the middle. These inequality symbols will stay the same, but in order to get x in the middle, we need to take away the 3. When you have numbers both sides, that's fine, you just take away the 3 from both of those numbers. So negative 2 becomes negative 5. Positive 4 becomes positive 1. Now we can plot that on our number line. So we want a circle above the negative 5, circle above the 1, join them up, and then we make a decision, are we going to colour either of these circles in? Now on the right inequality there, we do have the extra symbol on the inequality, or extra ink on the inequality, as I like to say sometimes. So we put extra ink in the circle, and that one on the right there is shaded in. And there is drawing an inequality on a number line. For question 5, it says, in a sale, the normal price of a book is reduced by 35%. The sale price of the book is £5.59. Work out the normal price. So we've got a reverse percentage. So here, I like to draw a bar model, just to imagine what this looks like. So we've knocked off 35%, and that means what's remaining is 65%. Those two have to add up to 100. When we're working out the normal price of the book, that's asking us to go back in the past. It's asking us to go back to the original 100% before that 35% was taken off. So we just need to read this line very carefully. It says it's reduced by 35% in the first line, but this second line says the sale price of the book is £5.59. It doesn't say it was reduced by £5.59, so therefore it's the 65%. So I'll just write down 65% is equal to £5.59, and then I always take the same approach, which is divide by this percentage to get 1%. So in that case, divide by 65, and then multiply it by 100. There we go. And of course, there are other ways of doing this. You can apply a multiplier method and reverse that. That's absolutely fine as well. I just like to use this method because it sits with me really nicely for when reverse percentages come up on a non-calculator paper as well. So I just like to use the same method. £5.59 divided by 65 gives us 0.086. So 0.086 would be 1%. Timesing that by 100, and I'm just doing it all on the calculator, gives me 8.6. Now this is money, so that's £8.60. So our final answer, £8.60, and there we go, our reverse percentage complete. Question 6, we have, here is a triangular prism. Work out the volume of the prism, give your answer to 3 significant figures. So to work out the volume of a prism, we need to know the area of the cross-section. The cross-section here is a triangle. Apart from, we can't get the area of that triangle without the length of the base. So on the front of that triangle, you do have a right-angled triangle. And to find the missing side on a right-angled triangle, when we don't have any additional angles other than the right angle, is to use Pythagoras. In this particular question, we are finding a shorter side. So after we square the sides, we're going to take them away from one another. So 8.4 squared, take away 7.2 squared. We'll get the answer for that. So typing that into the calculator, 8.4 squared, take away 7.2 squared, and that gives us 18.72. So that's 18.72, and of course, Pythagoras Theorem, we need to square root our answer. So for a square root answer on the calculator, that comes out as a relatively long decimal. So it comes out as 4.32, 3 6s, 1 5, 3 1. Now you could probably get away with rounding that slightly, although in the question it says give your answer to 3 significant figures. So you're going to want to round it to quite a lot more than 3 significant figures because you don't want it to affect your final answer. So in this case you could probably round it after those 6s, but for the sake of writing down an additional 4 numbers, I'm just going to leave it as it is. So now I have the base of the triangle. So what I can do now is I can do half base times height, or base times height divided by 2, however you choose to write it. So 4.32, 666, 1531, multiplied by the height, which is 7.2, and then divide all of that by 2. And that's going to give me the area of the triangle. So times 7.2, get my answer, then divide it by 2, and I get the area of the triangle is 15.57598151. To turn that into the volume then, I've got the area of the cross section, I just need to multiply it by the length that it goes through the shape. In this case that's 18 centimetres. So I just need to multiply my answer by 18, and that's going to give me the volume of this triangular prism. I've already got that on my calculator, so I'm just going to press times 18, and there we go. I get 280.3676672. So there we go, there is the volume of the prism. So we just need to make sure we get this now to 3 significant figures. So the first significant figure is the 2, then the 8, and then the 0, as that comes after a whole number. So if I chop after that 0, and then I'm just going to round that, it's a 3 after the line, so the 0 doesn't change, 280, and we've already got the units there, so we don't need to write centimetre cubed. Obviously be aware if they don't put the units there, then you're going to get a mark for putting the correct units. So make sure you put that in, because even if you make a mistake, chances are you might get a mark just for writing the correct units. On to the next question. So Demi is a skier. She completed the race in 1 minute 54 seconds. The race was 475 metres in length. Demi assumes that her average speed is the same for each race. Using this assumption, work out how long Demi should take to complete a 700 metre race. And give your answer in minutes and seconds. So we're looking at speed, distance, time. So straight away, whatever method you use, I would write down the formula for speed, distance and time. If you use a formula triangle, then we'd write SDT. So now, what are we working out? Well, based on that first bit of information, we are given a time, 1 minute 54 seconds, and we are given a distance. So we can work out her average speed. So to work out speed, it's distance divided by time. So we could work this out in metres per minute, or we could work it out in metres per second. It does want our answer in minutes and seconds, so it's completely up to you. We could go about working this out in seconds and then get our answer for the second part in seconds, convert it back into minutes and seconds. It's completely up to you how we go about this. So if you are going to do this in minutes, I think it's important because should a question like this come up, there is a way of writing 54 seconds in terms of minutes. You just need to divide that by 60. If I do that on the calculator, 54 divided by 60 comes out as 0.9. So that would be 1.9 minutes. You don't need to do that though. We can actually obviously do this in seconds. 1 minute 54 seconds would be 60 seconds plus 54, which is, we don't actually need a calculator because I've just typed in 60 times 54, and you definitely don't want to be making mistakes like that. So that right there is 114 seconds. So if we work this out in meters per second, we need to make sure that we label that so we don't forget. Then I would do the distance, 475, divided by the time, 114 seconds. And if we type that in, 475 divided by the answer, we get 4.1 and then 6 recurring, and that'll be meters per second. Now, if we assume then that she has the same speed, how long will it take her to do the 700 metre race? So this time we're trying to work out a time. We have a distance, 700 metres, and we have a new speed that we've worked out. So if we do that for the second part, we have 700 metres, and we want to divide that by the 4.16 recurring. You need to be very careful here. You don't want to round that. If we divide that by 4.16, it's going to give us the wrong answer. So you want to leave that 4.16 recurring on the calculator, and then do 700 divided by, and click your answer button. So that gives us 168. So 168. Be very careful, because if I did type in 700 divided by 4.16, it gives us 168.269. So it's going to give us a slightly different answer. So now we just need to convert this 168, which is seconds, and make sure that we write that in minutes and seconds. So there are 60 seconds in every minute. So that would be 60 and then 120. 180 would be 3 minutes, so it doesn't hit 3 minutes. So 120, if we take away 120 from that, we know it's 2 minutes already. And that would leave us with an additional 48 seconds. So that'd be 2 minutes and 48 seconds, and that'd be our final answer for that question. Looking at part B, it says Demi's average speed actually increases the further she goes. How does this affect your answer to part A? Well, looking at part A, if she actually went faster than this, well, of course, logically, she would actually do this in a faster time. So in terms of part A, that number there would get smaller. So how would we write that? We could say Demi would take less time there we go. So our answer would be less, or would be smaller, or would be a faster time. There you go, you could write any of those, but of course we are referring to our answer to part A as it's asked us to do. How does it affect your answer to part A? So there we go, there's that question, looking at some speed, distance, time and doing some conversions. Of course I did that in meters per second, but you could have converted it to minutes. I think it was more complicated to do it like that, and I preferred doing it in meters per second, so always try and look for the easiest route when doing one of these. So Oscar carried out a survey about the ages of people at his work, and the table shows information about his results. As soon as we spot there that it says cumulative frequency, that's good because it means that we don't have to add the numbers up ourselves. But have a look, because if it does just say frequency there, you're going to have to get the cumulative frequency yourself. But that's quite nice because that just means we need to plot it. It does say on the grid, draw a cumulative frequency graph. So not forgetting the cumulative frequency, we are going to plot on these endpoints, and also not forgetting to join up to our starting number, not necessarily the origin. Let's have a look, and our graph does start at 0 on the origin, so we don't want to be joining that up to the wrong place. We want to be starting from 20, and then we're going to plot the rest of our points. So 30 goes up to 10, then it goes up in tens along, so I'll go 40, 50, 60, 70, and then our next number is 26. So 10 along, and then we're going up to 26, which is 6 squares of 20, looking at the scale. Then it's 58, so up to 58, which is 2 squares below 60. Then we've got 66, so 60, 1, 2, 3, 4, 5, 6 just there. And then we have 70 on the final one, which is right at the top of the graph. There we go, so a cumulative frequency curve needs to be joined up as a nice smooth curve, not missing any of those points, so doing this very carefully. There we go, and then joining that up really nice as a nice smooth curve. So there we go, there's a cumulative frequency curve. Then it says use your graph to find an estimate for the median age. So in our cumulative frequency, there are 70 people. So to find an estimate, we are just going to divide that by 2 and go along from the 35th person. So along the cumulative frequency, which is on the left hand side, 35 is obviously in between 30 and 40. That's 1, 2, 3, 4, there's 35. So you go along with a ruler and a pencil until you hit your curve. And of course we're all going to get slightly different answers here because that curved part there can be different depending on how you draw it. So when I go down, I get 42. Now you might get 41, you might get 43. There's always going to be a bit of range that you are allowed. I would imagine you'd probably be allowed anywhere from 41 to maybe 44 or something like that. Okay, maybe even more. But there we go, my median age that I've got from my curve is 42. For part C, it says, Oscar says more than 60% of people in his work are between 35 and 55. Use your graph to determine if Oscar is correct. So if we have a look, how many people are between 35 and 55 years old? Not the easiest to do because we're drawing a lot on the graph now, but if we go up from 35, and let's get a different colour so we don't get confused between these. So 35 is up to there, and if I go across from 35, that lands on 17 people. If we go to 55 and go up to the graph, that's quite a way up, we're going to need to scroll up a bit. So all the way up to 55 there, and then across, that's just in between two boxes, but I'm going to do it as best I can. There we go. So let's just say that that's 62. So looking at that then, how many people are between this little section here? Well, we can work that out, 62 take away 17. Now, I'm not going to even try and do that, I'm just going to do 62 take away 17 on my calculator, and that is 45 people. So there are 45 people that are between 35 and 55. So what is that as a percentage of the total amount? Well, at the moment, there are 70 people on this graph. What is 60% of 70? If we work that out, 60% of 70, well, we can divide 70 by 100 times by 60, and we get 42. Of course, or you can write down 10% is 7, and then times that by 6. So 60% is equal to 42 people. So 60% would be 42 people. We've got 45 people. Oscar says more than 60% are between that age, so we would say yes. Okay, use your graph to determine if Oscar is correct. We say yes, he is. 60% equals 42 people, and 45 people are between 35 and 55. There we go. So there's our final answer for that part. Okay, so moving on to our next bit. Looks like we've got some standard form here, and that's definitely one that we can just type all into the calculator, hopefully. So if we type that in, let's just see. So we want to press our fraction button. So you need to know your calculator well for this, or you could work this part out on the top separately and rewrite it. Completely up to you. You're definitely going to get a mark for tidying up the top. But I'm just going to type it all in. So 2.56 multiplied by 10. Know where your power button is, because I want to do 10 to the power of 6. Multiplied by 4.12 times 10 to the power of negative 3. And on the bottom, 1.6 times 10, power button again, negative 2. Press equals, and that comes out as 659,200. So we have got that there. It now says, though, give your answer in standard form. So to convert this back into standard form, we need it to be between 1 and 10, so we want the decimal to go just there between the 6 and the 5. That would be 1, 2, 3, 4, 5 jumps. So if we write this out in standard form, that would be 6.592 up to the last whole number times 10 to the power of, and it was 5 jumps, and it is a large number, bigger than 1, so we have a positive power. So there we go, there is our number written in standard form, and that was just typing it into a calculator, so a relatively nice question there. Okay, so question 10. It says the straight line L has the equation 3y is equal to 4x plus 7. The point A has coordinates 3, negative 5. Find an equation of the straight line that is perpendicular to L and passes through A. So as soon as we see that word perpendicular, we know that we need to do the negative reciprocal when we're looking at the gradient. So we want to find a line that's perpendicular to this one. But at the moment, it's not in the form y equals mx plus c. So we want to divide that equation by 3 so that it is equal, or so that it has y equals at the start. When we do that, we just need to make sure we divide both sides by 3, so that will become 1y. This will become 4 divided by 3x, or 4/3 x, and then we get 7 over 3 at the end. So if we write down, and I always use the letter m for my gradient, m is equal to 4/3. We're looking at the perpendicular line, so the perpendicular gradient, which I always write as m with a little p, is equal to negative 3/4, the negative reciprocal. That's going to be the gradient of our new line. So if I write the equation of my new line with the correct gradient in, so it's y is equal to negative 3/4 x and then plus c. So the final stage here is for us to find that y-intercept, and we use this coordinate to do so, as we know that 3 and negative 5 is on that line. So we need to substitute those values into the equation. So y is negative 5, so negative 5 is equal to negative 3/4. The x here I'm going to put in a bracket, because that is a 3, and I don't want it to look like it's attached to the fraction, plus c. We now want to simplify this, or work that out. We could do that on the calculator. So we've got negative 3/4, and we're multiplying that by 3. That's negative 9/4, which is relatively easy to work out because you know that a whole number will just multiply the numerator, or of course you could write the 3 as a fraction 3/1, and then just use your fraction rules. So at the moment then we have negative 5 is equal to negative 9/4 plus c. So nice and easy to work out the value of c. We just need to add 9/4 to both sides. You could convert that into a mixed number and add it over, but we've got a calculator. So I'm just going to type in -5 plus, and then 9/4. And that comes out as -11/4. So we get -11/4 is equal to C. Now that is pretty much our final step there, because now we have all of the pieces that we need in order to write our equation. We know the gradient, which is up here, -3/4. We know the y-intercept, or the value of C there, -11/4. So we just need to put all the pieces together. So we've got y is equal to -3/4x. And then we're not going to write plus C because C is negative, so minus 11/4. And there we go, and there we are, finished. Y is equal to -3/4x, take away 11/4. Absolutely fine, you could write those as decimals if you prefer to work in decimals, but I tend to always leave it as a fraction. Okay, on to our next question. So we have a circle sector. It says the diagram shows a sector of a circle of radius x. The area of the sector is 36.3 centimetres squared. Work out the value of x and give your answers correct to the nearest centimetre. So looking at this, immediately they're going to try and throw us here because they've given us this angle of 100. But within the sector, we're interested in this angle here. So we want to take that 100 away from 360, and that leaves us with 260 degrees that we're going to use in the sector. Now if we think about how we would work out the area, I know we've been given the area, but we're going to have to reverse this. We're going to need to set up a formula. So how would we go about working out the area of a sector? Well, we know area of a circle is pi r squared, so we would do pi times the radius squared, multiplied by the fraction of the circle that we're looking at, which we'll call theta over 360, and that would equal the area, which we've got, 36.3. So if we just look at the pieces that we've actually got in our question and put them into our equation, we have pi multiplied by, the radius is x, so multiplied by x squared, multiplied by the angle that we're looking at, which is our 260 degrees, so multiplied by 260 over 360, and that is equal to 36.3. So on to the next step, we need to now rearrange this. So what we want to do is leave the x squared on its own. So we can divide both sides by anything else that's on the left hand side. We've got a few bits on the left hand side. We've got pi that we can divide to the other side, and we have this fraction 260 over 360. So it looks a bit messy, but we can say that x squared is going to equal 36.3 divided by 260 over 360 pi. And you can probably type that into your calculator and make it look a little bit neater, but I'm just going to write it all like that because that is going to tell me what x squared equals. I'm going to type it in my calculator just like that. If you don't have a sort of scientific calculator, which hopefully you do for this higher exam, but if you don't, you could type those pieces in individually and then type them in as a divide. But 36.3 on the top, and on the bottom I've got a second fraction, so 260 over 360, and then press shift to get my pi, press equals, and I have 15.99874,459. Now that is the value of x squared, but we want to know the value of just x. So to get the value of x, to reverse a square, we're going to do a square root. And if I square root that, I can just press square root answer on my calculator. And let's see what we get. So we get x is equal to, and I get 3.99984,307. So obviously correct to the nearest centimetre, that is going to be 4 centimetres. And there we go, there's my final answer for that reverse area of a sector. Right, so there we go. On to our next one. Prove algebraically that 2n plus 1 squared take away 2n plus 1 is an even number for all positive integer values of n. So what I actually need to do is simplify and tidy up what we've got. So 2n plus 1 squared I'm going to do first because that is a double bracket. So that would be 2n plus 1 and another 2n plus 1. And when it comes to algebraic proof, I just need to tidy it up, and when I get to my final part, that's when I'm going to try and show that it's an even number. So to do this, expand our bracket. 2n times 2n is 4n squared. 2n times 1 and 1 times 2n will both give us 2n, so it's going to be 4n in total. You can write that in 2 steps if you like, and then add them together. And then 1 times 1 is 1. Now from that, we're going to take away 2n plus 1. Okay, we can put that up here as well if we want, just to show the full steps as we are proving algebraically. You've got to be careful when you do this with the takeaway, because we are going to be taking away the 2n and we're going to be taking away the positive 1. There's no n squareds, so we're going to be stuck with the 4n squared. Then we have the 4n, and we are going to take away 2n. So that leaves us with plus 2n. And then we also have the 1, and we're going to take away this 1 here. So they cancel out, so we've got no numbers left. So our final expression here is 4n squared plus 2n. Now there's a couple of different ways that you can prove that something is even, but ultimately we need to take out a factor of 2. Both of these divide by 2, so I could just put 2 on the outside, and then on the inside I would have 2n squared plus n. Now that means that anything that I substitute into this expression will ultimately get multiplied by 2. So here I could just write always multiplied by 2 . There we go. And I could just say therefore always even. There are a couple of different ways that you could factorise that. To be fair, you could take out a factor of 2n. So you could have written 2n, and then what times 2n makes 4n squared. That'd be another 2n, and then 2n times 1 would give us that 2n. So you could have factorised it like that as well. That's just another way, and then of course everything here is always going to be multiplied by 2, so it's always going to be even. But I'll leave that up to you, completely up to you how you decide to factorise that at the end. But the point here was that we were able to factorise out 2, so we've shown that it's always going to be even. Okay, on to question 13. So it says A and B are points on a circle, centre 0. DBC is the tangent to the circle at B, and angle AOB is x. We can see all of that on the diagram. It says show that angle ABC is a half x. You must give a reason for each stage you're working. So if we look at this then, let's have a think about the angle we're trying to find. We're trying to find the angle ABC, which is this one here. So that's the one we're trying to find. Let's not put an x in there because it's not the same as that value. Let's just put a question mark there for the moment. So in terms of algebra, how do we go about finding that? Well, this triangle here that you can see, this is always the one that people tend to miss, that is an isosceles triangle, as both the radius here and the radius here obviously have the same length. So that's an isosceles. When we're finding the base angles in an isosceles, we would take away that top angle from 180 and divide it by 2. So to get both these angles here, and let's just do this to the side, we do 180, take away x, and then divide it by 2. We could simplify that. That would equal 90 minus a half x. So that angle there we could write as 90 minus a half x. Let's just write that relatively small inside the angle here. So 90 minus a half x. And again, you could write it on the other side if you want. Now that's getting us somewhere because we've got this half x that's appeared. So now we just need to think about how that relates to the angle in the question mark. Well, it tells us that that line is a tangent, and straight away that means that this full angle here is 90 degrees. So if we think about how we would find the gap there, well, we would do 90 degrees and we would subtract this angle here. And that would give us this part that we're looking for. Now if we write that down, we've got 90 degrees, take away, and this is where we need to be careful because we have a similar scenario that we just had in the proof. We are taking away two things, so we put this in a bracket. So take away 90 minus a half x. Now this means, and we get something a little strange happen here, we have 90 take away 90, so these two are going to cancel out because 90 take away 90 is 0, and then that would leave us with nothing take away negative a half x. Now if we take away negative a half x, take away, or if we write this out, 0 minus minus a half x, it's a strange thing to write, but these two negatives become a plus. So 0 plus a half x would equal 1/2 x. And there we go. Now this question said you must give a reason for each stage you're working. So for each step, if you were to write it below, I've kept the screen up here so you can see the question, but you could write that next to all of your working. So let's just go and add in our reasons for every step. So this one here, we did 180 take away x divided by 2 because base angles in an isosceles are equal. There we go. And it is fine just to label these things right next to your working out all around the sort of diagram. We also had, if I just sort of work from my diagram here, this 90-degree angle. That's because the tangent to a circle is perpendicular to the radius. So we'll write that in, the tangent to a circle or forms a right angle with the radius. It doesn't really matter how you write this. I'll write is perpendicular to the radius. Did we do anything else? That's pretty much all that we've done there. So we have, I mean, we could write angles in a triangle are equal to 180, but I don't think we necessarily need to. We did base angles there, base angles, and then we took it away from the radius. So I think that's absolutely fine in terms of the reason that we've given. We don't need to overload the reasons, but of course when you are asked for reasons, particularly with a circle theorem question, you are normally making sure that you at least give one reason which is actually related to the circle theorem. And in this case, that's our tangent to the radius. Now there are probably other ways of answering this question. That's absolutely fine. If you've got a different method of doing it, that's brilliant, and definitely drop a comment in the comments to let me know if you've got a different way, because I really like circle theorem questions, how there's normally more than one route of getting to your answer. Okay, on to question 14. So it says here, Amber is trying to find the density in grams per centimetre cubed of a block of wood, and the block of wood is in the shape of a cuboid. I'm just noticing already it's not given us a picture of the cuboid. She measures the length as 13.2, correct to the nearest millimetre, the width as 16.0, and the height is 21.7, and they're all correct to the nearest millimetre. She measures the mass as 1,970 grams, correct to the nearest 5 grams, and then it says by considering bounds, work out the density of the wood, give your answer to a suitable degree of accuracy. You must show all your work and give a reason for your final answer. So when we're working with bounds, we need to write the error interval for all of these. We will usually always get marks for getting some of the error intervals. So even if it's a really complex question, we can get some marks for a lower grade part of the topic, which is those error intervals. So for the 13.2, our error interval for that, and make sure obviously you know how to write them, we add a 5 on for the upper bound, so 13.25, and if we add a 0 on the end, it can help to visualise, it'd be 13.15 on the left. The same for the one below. If I start with the upper bound, it'd be 16.05. This is actually a little bit nasty going back the other way because it will drop down to 15 and it'd be 0.95. For the last one there, let's just draw our error interval properly. That would be 21.75 and it'd be 21.65 on the left. So there's our error intervals. And then we've got another one that we need to do here. For the mass, it says this is correct to the nearest 5. Now when it's correct to the nearest 5, that's always one that tends to throw people because that means it could have been 2.5 grams higher or 2.5 grams lower. So our error interval for that one is going to be different to our other error intervals because that means it could have been 1,972.5 and on the lower end it could have been 2.5 grams less, which would be 1,967.5. And just double check that and make sure you're happy that you've written that correctly, because that one can sometimes just cause a little bit of confusion. So this is in the shape of a cuboid and it wants us to find the density of the wood. So straight away it's mentioned density. We've probably already picked up quite a lot of marks here, but the density, we're going to want to know our density formula. Definitely don't write your speed formula. So density is equal to mass over volume. Whether you write that as a formula or you use a formula triangle is completely up to you. But if we are working out density, we need to do the mass divided by the volume. So if I write that as a formula, density equals mass over volume, because we have two scenarios now. So when we are considering bounds, which this one asks, we need to check both scenarios. And that means we could have the lower bound of the density. You've got one option. So the lower bound of the density, in which case we'll need to do the lowest number on the top divided by the biggest number. Or you could have the upper bound of the density, in which case we'd want the upper bound on the top divided by the lower bound to give us the biggest possible number. So with a cuboid, we know that the volume is relatively easy to find. You just multiply the three numbers together. Obviously, just thinking about a cuboid, you can always sketch one if it makes you feel better or you like to visualize it, and then label all those lengths on there. I'm not going to label them all on. And we're going to divide that into the mass. So we want to make sure we're picking the right numbers. So if we start with the lower bound, then we want the lower bound of the mass. So up here that's 1967.5. And the upper bound of the volume, which is going to be these three numbers multiplied together. So if we do that to start with, the lower bound will be equal to 1967.5 divided by all those numbers times together, so 13.25 multiplied by 16.05 multiplied by 21.75. Of course you could work out the volumes separately and then use that number, but I'm just going to stick it all in one go. So pressing my fraction button, 1967.5, and on the bottom 13.25 times 16.05 times 21.75, and just have a look and double check that you've not typed in anything wrong, because that's quite a lot to type in. And we get a lower bound of 0.4253677546. And there we go, there's our lower bound. To work out the upper bound, we're just going to basically do exactly the same thing, but in reverse. So if I get rid of these ones that we just used, and we are going to reverse that, and we are going to do the upper bound of the mass divided by the lower bound of all those lengths. So the upper bound of the mass, 1972.5, and we're going to divide that by, let's have a look, 13.15 multiplied by 15.95 multiplied by the last one, 21.65. So there we go. Type that all in on the calculator. I'm going to delete what we had there before because we don't use any of the same numbers. So 1972.5 divided by 13.15 times 15.95 times 21.65. And there we go. That gives us 0.434382, and there are more decimals, but I can already see how it's going to round it. There is a 0.6 after that 5, but we're not going to need to go that far. So we now have both the bounds. All we need to do is write what our final answer is going to be using a suitable degree of accuracy. So if we look at these numbers, do they round the same to 3 decimal places? Well, if I was to cut after this decimal and this one, that would be 0.425, and the other one would be 0.434. So they don't round the same to 3 decimal places. If they did, I'd probably want to just check 4 decimal places because I want to get it as accurate as possible, but they don't. So I'm going to now jump to 2 decimal places. So if I cut it there and cut it here, the number on the left, 0.425, would round to 0.43. And the number on the right, 0.434, would also round to 0.43. So we have a match, and that's what we're looking for. So the reasoning for this, And again, you could use the reasoning of significant figures, or you could use decimal places. In this case, as it's a 0-point number, this is both two significant figures and it's two decimal places. So my final answer for this one would be 0.43, and I would just write the reason there, which is two decimal places, or of course, like we mentioned, you could write two significant figures. And there we go. That is how we do bounds when we are considering bounds, and that's quite a big question there, so we've got a lot of marks at 5 marks, but as I said, you've got a couple of marks in that question just for writing down the correct error intervals, and then it was just about plugging them into our density formula. Okay, on to our next question. Okay, so we have some geometric proof. Now it says here ABCD is a parallelogram, and if we kind of draw over that, we have A to B, down here to C, and over to D, and when all of that is joined together, that's our parallelogram. It says ABP and QCD are straight lines. Angle ADP is equal to angle CBQ, which is 90, and that's shown to us on the diagram. Prove that triangle ADP is congruent to triangle CBQ. So let's find those triangles. So A to D to P is this triangle here. Okay, and the other triangle, CBQ, is this triangle, C to B to Q. There we go, so it's all overlapping, it all starts to get a bit messy. So what we need to find is, using the information, we need to find any sides or angles that are the same in both of those triangles. And ideally we'd write this as some 3-part proof, and then obviously a conclusion at the end. Now, one thing that stands out to me straight away is that they both share a right angle, and straight away that gives me something that's the same. We're actually told that in the question. So if I do this in bullet points, we've got angle ADP is equal to angle CBQ, and they're both equal to 90. Now what we can write is that it's given in the question, but next to that I'll just put here both 90 degrees. You could write there as given in the question. So that right there is an angle. So I'm just going to write an A there so I know how to write my conclusion. If we then look again at the triangles, thinking about that parallelogram, is there any other angles that are the same? Well, within that parallelogram, which you can hopefully still see there, ABCD, you've got this angle in the bottom of that green triangle, and you've got this angle here in the top of that pink triangle. So there, those angles are opposite angles in a parallelogram, and opposite angles in a parallelogram are equal. So that's another angle which we found in both triangles that's the same. So the angle in the pink triangle is PAD or DAP, however you want to write that. So angle DAP is equal to angle, and let's find that angle in the green triangle, BCQ. So angle BCQ, and our reason for that, opposite angles in a parallelogram are equal. There we go, so opposite angles in a parallelogram are equal. There we go, and that is another angle. Now, you can't prove congruency with 3 of the same angles. Okay, you can prove similarity with that, but we don't know that they are congruent unless they share a side that is the same length. So I need to find a side now. So again, looking at that parallelogram, well, the top and bottom of the parallelogram are not the full lengths of the triangle, but the left and right of the parallelogram, this line here and this line here, they are a full length on the triangle. So those lines are the same length, and that's because opposite sides of a parallelogram are equal. So that's the side length AD and the side length BC. So we can write that down. We can go side AD is equal to BC. And again, we would say opposite sides in a parallelogram are equal. I'm going to run out of space here. Parallelogram are equal. and that there now proves that they are congruent, as we have a side length and two angles. So to finish this off, I would do I'm going to write it above, I'm going to write a conclusion, so I'm going to say therefore, and let's just mention what it asked. It said, therefore, triangle ADP is congruent to triangle CBQ, okay, as they are ASA triangles. There we go, and there is your congruency proof and your conclusion at the end. So there we go, there is some geometric proof, and hopefully when you actually look at that, it's not actually too bad. Finding them initially is the pain, and hopefully you'll see that actually having a few highlighters for these papers can be really helpful, just in case one of these comes up. At least you can highlight some different side lengths. So question 16, we have some functions. So it says here, for all values of x, f of x is x plus 1 squared and g of x is 2x minus 1. Now straight away, before I even move on to looking at part A and B, I don't like how that looks because they are already in brackets. So before I even move on, I'm going to expand these. So that is x plus 1 and another x plus 1. So that would be x squared plus 1x plus 1x, so plus 2x plus 1. And this one, just expanding both of those by 2, so that'd be 2x minus 2. It says that show that gfx is 2x brackets x plus 2. So again, they factorise that as well. I'm not going to expand that because they want us to show the factorised form. So gfx means it wants me to put the function f into the function g. So when I do this, I just put a bracket around the function f, a bracket around the x where it's going, and I just put all of that into that bracket there. And if we do that, we get two lots of x squared plus 2x plus 1, and then take away 2. And if we tidy this up, you get 2x squared plus 4x plus 2, and then minus 2. Now obviously the plus 2 and the minus 2 just cancel out, so we're left with 2x squared plus 4x. That factorises, so we can take out a factor of 2, or we could take out a factor of 2x, and it wants us to fully factorise it as they've got the 2x in the question there, so that would be x plus 2 inside the bracket. That matches what they've asked us to show, so there we go, 2 marks. You don't have to do any additional explanation from here to here. Essentially, once we got to that point, we've kind of just written the answer that they've asked us to show, but there we go. As long as you have the line correct above that, that's going to be absolutely fine. Part B wants us to find the inverse function of g and then to substitute 7 into it. Now there are lots of different ways that you can go about doing this. There are kind of little tricks to inverse functions, but I think the best way here is just to write down the function of g, which is equal to 2x minus 2, do the inverse, make sure we get a mark for that, and then substitute the 7 in. So when I do the inverse function, I get rid of this g of x, I write y equals, and then I make x the subject, so add 2, so y plus 2 is equal to 2x, divide by 2, we've got y plus 2 divided by 2 is equal to x, a bit messy there, and then swap the x and y back over. So the inverse function of g is equal to x plus 2 divided by 2. Now they've got the 7 in the bracket, so they do want us to substitute 7 into there, so that's nice and easy for us to do. It'll just be 7 plus 2 divided by 2. 7 plus 2 is 9, so it's 9 over 2, or you could write that as a decimal, you could write that as 4.5. As you've got a calculator, you may as well, but you could leave that as 9 over 2. But there we go, 4.5 is our final answer, and there's an inverse function, and obviously we had a composite function there in part A. Okay, on to question 17. So it looks like we're going to have a graph transformation. We've got the function of x is shown on the grid, and there we go, there's our graph. It says on the grid, draw the graph with equation f of x plus 1 minus 3. Now anything inside the bracket affects the x coordinates, and it does the opposite of what you think. Anything outside the bracket affects the y coordinates, and it does exactly what you would think. So the easiest part to do here is that y coordinate, because that minus 3 just moves the y-intercept down, or all the y coordinates down by 3. In the bracket though, that there does the opposite. So rather than moving it +1 to the right, it actually moves it -1 to the left. Okay, or you could just say 1 to the left. Don't necessarily need to say -1 to the left. So that represents going 1 to the left, and this represents going 3 down. So each point that we can see, or every whole number coordinate, needs to go 1 left and 3 down. And that can be a little bit of a pain to draw, particularly when we've got to do a few different points. So I can see a few whole number coordinates. We've got 1 there, 1 there, 1 here, and 1 there. Of course, you can just move one coordinate, and then if you can replicate the pattern, absolutely fine to do that as well. So if I pick this coordinate here, I need to go 1 to the left, and then 1, 2, 3 down, and that's going to end up there. So that is really awkward to draw because that is going to go over the x-axis. So that's going to be 1 across. Okay, and now I'd probably want to just get rid of a bit of this, and then it's going to go down to here, replicating that. Then it goes across 3 diagonal squares up to there, and then it goes across by 2 extra squares. So there we go. You're going to have to draw that a little bit thicker over the x-axis just to make sure it's clear that you've drawn that final part in. But there we go. That has gone 1 to the left and 3 down. Of course, you could write that as a vector as well. You could say that that is the vector -1, -3, which just means 1 left and 3 down. But there we go. There is our translation of that graph there, that function. For part B, we've got point A, -2, 1, lies on the graph of the function of x. Can we see that? -2, 1, yep, we can see that there. So point A, there it is. When the graph of f of x is transformed to the graph with equation y equals f of -x, point A is mapped to point B. Write down the coordinates of point B. This is always a bit of a strange one, particularly if you learn that in the brackets it's always the opposite of what you'd expect. That sort of changes when you have -x. -x has to do something, and the opposite of -x would just be +x, so it always seems a little bit strange. -x, all it does is it changes the symbol in front of the x coordinate. So at the moment, if we look at that point, x and y, we have -2 and 1. So for -x, it's just going to change this x coordinate, and it's just going to become +2. The y coordinate's not going to change, it's just going to be 2, 1. So this is the function f of x, and for f of -x, we get +2 and 1. So there we go, a relatively nice and quick and easy one when you know that, but just a little bit of an explanation behind that. Okay, so graph transformation's done. On to our next question. Okay, so this question says that there are 6 black counters and 4 white counters in bag A, 7 black counters and 3 white counters in bag B, and then 5 black and 5 white in bag C. Madison takes at random a counter from bag A, puts it into bag B, then she takes a counter from bag B and puts it in bag C. Find the probability there are now more black counters than white counters in bag C. Well, there's only going to be a few scenarios where that can actually happen. So before we start thinking about any fractions, if we think about a root on a probability tree, if this is bag A, and we're going to take a black counter or a white counter, then this is our bag B, and again we're going to take a black counter or a white counter, black counter and a white counter. There is only 2 scenarios there where we would end up with more black counters than white counters. It doesn't matter what we take out of bag A, but if we take a black counter out of bag A, we would then need to take a black counter out of bag B in order for the black counter to go into the 5 white counters, the 5 black counters in bag C, and make sure that there was 6 black and 5 white. You have the other scenario whereby we might take a white counter out of bag A, but then we'd only be able to take the black counter out of bag B to again make sure that there were 6 black counters as opposed to 5 white counters. So we just need to work out those 2 roots on this probability tree. This actually sounds relatively complex, this question, but when you think about that, it's not actually too bad. But getting these probabilities isn't going to be the nicest. That's okay for bag A because we have 6 out of 10, because we have 6 black and 4 white. So 6 out of 10 and 4 out of 10 for our probability tree to start with. Then we just have a slightly different scenario based on what colours are taken out. So in the second bag, you've got 7 black and 3 white. If you take a black counter out of bag A and it goes into bag B, you won't have 7 black, but you'll have 8 black counters, and instead of being out of 10, that's now going to be out of 11. The amount of white counters isn't going to change, so you're still going to have 4 white counters in the bag, but now out of 11, as you've got the additional black counter there. If you took a white counter out of bag A, then a white counter would be added to those 3 white counters that are in there at the moment. But in terms of black, the black counters wouldn't change. There were 7 black counters in bag B. So there'd be 7 black counters, but there's going to be 11 there now because a white one has been added in. The white counters wouldn't be 3 in bag B, they'd be 4, as we were taking a white counter out of bag A. So that'd be 4 over 11. Now we obviously didn't need to complete the tree there because we actually only care about these roots where we get a black counter from bag B, so that a black counter is added into bag C, which would mean that there would be more black counters than white counters. So we just need to work out these 2 roots. So for this one, we would do 6 over 10 multiplied by 8 over 11. And for the bottom one, we would do 4 over 10 multiplied by 7 over 11. Now again, you can just work these out on the calculator. It's quite easy to see that the denominator there is going to be 110. But you can just type these in on the calculator. Let's not write 100, want to make sure we write 110. Again, we obviously don't need to use a calculator here, but let's just type it in just to make sure we don't make any mistakes. So that's 48 over 110, 4 times 7 is 28, so 28 over 110. So in this question, we have 2 probabilities. You've got 48 out of 110 and 28 out of 110, and we just need to add those 2 together. Remember, we want to show the working out here, so 48 over 110, add the 28 over 110, and that gives us a total of 76 out of 110. So that is the probability that there's going to be more black counters than white counters. And remember, with probability, you don't need to simplify it, so just 76 over 110 is absolutely fine. As it's on a calculator paper, I could type it in. I mean, you're wasting time doing it, but 76 over 110 simplifies to 38 over 55. That would be correct as well. Any equivalent fraction that is 76 over 110 is absolutely fine. So there we go. That's a little bit of a tricky one. If you weren't happy with the language of that question, you may want to go back and re-watch that one, but we're going to carry on. So question 19, we have some algebraic fractions. So this here says 2 take away, and we have an algebraic fraction, take away another algebraic fraction. It says it can be written as a single fraction in the form ax plus b over x squared minus 9, where a and b are integers. Work out the value of a and the value of b. Now when we are going left to right with addition and subtraction, we have to work from left to right. So I'm going to start by doing these first 2 fractions. So 2 we would write as 2 over 1. I'm going to take away x plus 2 over x minus 3. So that's what I have to do first. If I do that, I want to make a common denominator, so I want to times the left by x minus 3, top and bottom. And that will give me a common denominator of x minus 3. If we do that, I'll have 2x minus 6 on the top and x minus 3 on the bottom. And now I'm going to take away the x plus 2 over x minus 3. That's easy enough to do. On the top, you've got 2x take away 1x, which is 1x, and you've got negative 6 take away 2, which is going to be negative 8. So you have x minus 8 over our common denominator, x minus 3. Now we can take away what we had in the third part of that algebraic fraction. So now I'm going to take away the x minus 6 over the x plus 3. That's going to be a little bit more complicated than our last one because our common denominator is going to be a little bit harder to get. Although at this point we know we're on the right track because x minus 3 and x plus 3 are going to make this x squared minus 9 that it was asking us to do. So we need to make a common denominator. We're going to times the right, top and bottom, by the x minus 3, the denominator in our left fraction, this one here. And I'm just going to write that over on the right. So we're going to times by x minus 3, times by x minus 3. And we're going to do the same to the left-hand side. We are going to multiply by the opposite denominator, x plus 3. I'm just going to write that in here, so times by x plus 3. I just don't want to forget what I'm multiplying by halfway through, so times x plus 3. Now that's going to be relatively quick to do on the bottom, but on the top we are going to have a double bracket for each of those. So we might want to just work those out separately. So this one here, we're going to have to do x plus 3 and x minus 8. That's going to give us x squared minus 8x plus 3x would be minus 5x. 3 times 8 will be minus 24. Take your time expanding those. This one here is going to be x minus 6 multiplied by x minus 3. And that's going to give us x squared minus 3x minus 6x, which is minus 9x. And then 6 times 3, negative 6 times negative 3 will give us positive 18. So we've got our numerators. That is going to be on the left, x squared minus 5x minus 24, all over the denominator, which we're going to get in a second. And on the right, we have x squared minus 9x plus 18. Now our denominator is going to be a difference of two squares. We've got x minus 3 and x plus 3. And that's a really nice one to expand, x plus 3 and x minus 3. As the middle two terms cancel out, you just end up with x squared minus 9, which is perfect because that's what it wanted in the question. So we've got our common denominator. As long as we have expanded those brackets on the numerators correctly, this should all fit together perfectly. So now we need to simplify the numerator. So looking very carefully, we've got x squared take away x squared. They're going to cancel out. We've got negative 5x take away negative 9x. So that's going to become a positive, and that's going to be 4x. So negative 5 add 9 will be 4x. We then also have negative 24, and we're going to take away 18. So negative 24 take away 18. And again, don't forget you've got a calculator. To be fair, let's just type that in. Negative 24 take away 18. And that's negative 42. So 4x minus 42 all over x squared minus 9. And there we go, that is written as a single fraction. So it says also, almost missed that, work out the value of a and the value of b. So looking, the value of a is the number in front of x, the value of b is the number at the end, and there is a plus there. So let's just have a look. So in front of x we have a 4, so a equals 4. And in front of b, well, the b itself, as it says plus b, we are going to have to incorporate the fact that it's negative, so b equals negative 42. Just a little side note there, if they put ax minus b on the top, then you wouldn't have to put the minus with the 42 because it was already telling you it was negative. The b would just be the value there. But as they've put a plus symbol, we need to incorporate the fact that it is negative. And there we go, on the dotted line, it asks us for a, which is 4, and it asks us for b, which is negative 42. And there we go, there is some algebraic fractions. Okay, on to question 20. It says the centre of a circle is the point with coordinates negative 1, 3. The point A with coordinates 6, 8 lies on the circle. Find the equation of the tangent to the circle A. Give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So this is an off-centre circle. So if we were to draw this, and let's imagine what it looks like, that's going to really help. So negative 1, 3, let's just imagine that's somewhere here. So if that is the centre of my circle, and again this is just a sketch, it's not going to be a very good drawing, it looks something like that. The point with coordinates 6, 8 lies on the circle. So 6, 8 is going to be in our positive quadrant. Let's just imagine that that is here. There we go, and let's just label all these. So minus 1, 3, and that point there is 6, 8. Finding the equation of the tangent to the circle at point A. So this is point A. Now in order to do that, we're going to need to know the gradient of the radius. To get the gradient of the radius, we can just have a look between those 2 points. Once we've got that, we can then find the negative reciprocal for the gradient of the tangent and sub those points in. This actually isn't as bad as it first looked. to get that gradient from there to there, we can do the rise over run, or the change in y over the change in x. Let's just have a look at what that looks like. The change in y goes from 3 to 8, so that is a height of 5. The change in x goes from -1 to 6, so that is a run of 7. So the gradient of the radius, I'll write this here, the radius, we get rise over run, or change in y over change in x, would be 5 over 7. We want the perpendicular gradient, as we're looking at a tangent. So for the perpendicular gradient, which we've looked at already, we would do -7 over 5. And there we go, we've probably got a couple of marks at this point. At this point, we're going to follow a very similar process to when we were looking at perpendicular lines. So we're going to put that into our line equation. So we get y is equal to -7 over 5x plus c. And of course, we now need to put a coordinate in. We've been given the coordinate 6 and 8. So if we put that in, y is 8. So 8 is equal to -7 over 5 multiplied by the x coordinate, which is 6, and then add c. I'm going to type that into the calculator. So -7 over 5 multiplied by 6 gives me -42 over 5. So we get 8 equals -42 over 5 plus c. And again, solving that for c, we want to add 42 over 5 to both sides. So we can do 8 add 42 over 5 on the calculator, and we get 82 over 5, or we could write that as 16.4. I'm going to write it as 82 over 5, as I always like to leave this in fractions. So c is equal to 82 over 5. There we go. So we can write the equation now, which is y is equal to -7 over 5 x plus 82 over 5. So there is the equation of the tangent, but this question says it wants it in this form. It wants it in the form ax plus by plus c. It wants it equal to 0, and a, b and c need to be integers, so they need to be whole numbers. So if we go down, how would we do that? Well, in order to turn them all into integers, we can actually just multiply everything by 5, as we have 5s on the bottom. When we do that, they'll disappear, so we'll get 5y is equal to -7x plus 82. So that's got rid of that problem there with the fractions. We now just need to move everything to the left. So we're going to add 7x and take away 82 from both sides, and we'll put it in the order that it asks for. So we wanted x, then y, then the number. So I'll drop that 7x at the front, so 7x. This is a plus 5y, so plus 5y. We're minusing 82, and that is all equal to 0. So there we go, that would be our final equation. We've got integers, we've got it in the order that they've asked for, so 7x plus 5y minus 82 equals 0. And there we go, there is our final mark for that question. Okay, on to question 21. Let's just have a look. Yep, this is the last question, and there we go, it is a vector question. Okay, so usually the question that requires the most amount of thought, but it says OAB is a triangle, OPM and APN are straight lines, M is the midpoint of AB. Right, so as soon as it starts to say this, I start to put the fractions in, so that's a half, and that's a half. O to A is A, so O up to A, that's the vector A, and O to B, all the way along, is the vector B. O to P, P to M is 3 to 2, so that's out of 5. So O to P, this would be 3 out of 5. P to M, this would be 2 out of 5. Work out the ratio O to N, N to B. So what's the ratio from here to here and here to here? Right, so let's have a think. Now, in order to figure that out, we'd need to know how to get from O to N, or part of the way across. We'd also then need to think about how we would do that. So we could probably do that by going down one of the other lines. Now at the moment we don't know the vector A to B, we don't know the vector O to M, we don't know the vector A to N. So let's start thinking about some of these, which ones might be the easier ones, and think about therefore how we would get there. So if I look at the vector a to b, I can find that one relatively easily, and this is a really good part of the question where you just want to sort of bag some marks for finding any of the missing lines. So to get from a to b, I could go from a to o, which should be minus a, so going backwards through a, and then add b. Now, even on vectors, if you're not sure on these, and it's always the one that you leave, you're going to want to get one of those, because that gets you at least, potentially gets you a mark. You might then want to have a think about how you could move part way down that line. So it says that m is the midpoint. So I'll be able to get from a to m. If I can get from a to m, that might help me move part way across from o to m or something like that. And then we're starting to actually get through parts of other lines. Now m is the midpoint. So if I do half of that, or half multiplied by minus a plus b, that would allow me to get from a to m. And if we simplify that, that'd be minus a half a plus a half b. And again, you can rearrange that if you want. You can write half b minus half a, doesn't really matter. Completely up to you. So now I can get from a to m. If I can get from a to m, that means I can get from o to m, which I can move by going from a down to o. If I draw this on, I could go from a down to o, and then I could go from there to there. Now that is going to be the same as if I go from o to a and then a to m. So we've got a to m. So if we go that way, o to a, which is adding a, and then minus half a plus half b, that's going to get me from a to m, or from o to m. So let's write that one in. So o to m. So o to m, what do we say? Plus a, so a, and then adding this vector a to m that we've got written above, so minus a half a plus a half b. And if we simplify that, 1a take away a half a will just leave us with a half a plus that half b. So now we can get from o to m. Let's get rid of that. How does that help us? Well, if we can get from o to m, then we can get from o to p, and then we're starting to think about moving down the line a to n and, and things like that. So now we can actually get from here to here, because it tells us that that's 3/5, and we know how to get all the way across, so we can definitely go 3/5 of the way across. So again, let's have a look at o to m. So o, and what was that letter in the middle? P. So o to p, that is going to be 3/5 of the vector we've just done, so 3/5 of a half a plus a half b. So multiplying that by 3/5, that'd be 3 on the top, 5 times 2 is 10 on the bottom, so 3/10 a plus 3/10 b. Now that is getting us from o to p. Now let's have a think about how that helps us, because now we can probably start to think about how we would get to n. And we get to n by going from a to n. Okay, obviously from O we'd go up to A and then down to N, but we're doing this in stages. So now I can get from O to N, A to N, because we can use this O to P. Right, let's have a think about how we would do this. So we've got O to P, and then to get from A to P, we don't want to go all the way down to N just yet. So A down to P, how would we do that? Well, to do that, all we would need to do would be to go down from A to O and then up this line that we've already got. So we've got those vectors. So now we can get from A to P. So that would be minus A going from A to O. And let's write this down. This is from A to P. So A to P. And what was it? Was it minus A? Let's have a look. So minus A, because we're going backwards through A. So minus A, and then we would do the vector O to P, which we've got written above. So minus A plus 3/10 A plus 3/10 B. We just simplify that. So minus A plus 3/10 A would be minus 7/10 A plus 3/10 B. And of course you can rewrite that if you want. So now we can get from A to P. Let's just get rid of all of this and now have a think about what we can do from there. So to get from A to N, we know that that is going to be a multiple of the vector A to P, because it's the longer length of that. And we also know that we can get from a to n by going minus a and part of b. So this is the problem that we have, because we can't really find any more vectors. We can get from a to n by going down a minus a plus a part of b, that part that we don't know. We also know that we can get from a to n by doing a to p and multiplying that by some multiple to get that further part of the line. And if we translate that to bits of algebra, that means we've got two unknowns. So if we think about one of those unknowns, let's do a to n. So a to n in one way, and let's do this one first. So minus a plus an amount of b, and let's call that amount of b k. So we are going to go minus a plus an amount of b, so minus a plus kb. Let's think about the other option that we had. So the other option that we had was to do a to p and then multiply that by something to get the full length of the line. A to p we've already done, we've just worked out that vector. So another way of getting from a to n is we could do that vector multiplied by something. And we don't want to use the letter k because this is a different thing that we're going to be multiplying by. So let's just say x lots of, and then minus 7/10 a plus 3/10 b. There we go. So they are the two different ways that we can get from a to n. And of course, once we know how to get from a to n, we can think about the actual ratio of that line. So if we actually make a comparison here, let's think about what we have. Now if we were to expand this bracket for a to n, that would be minus 7/10 xa plus 3/10 xa. So you can expand it as well. Now if we think about these multiples, or these coefficients of a and the coefficients of b, sorry, that should be a b at the end there. So the coefficients of a and the coefficients of b obviously should be equal, because this is the same line, it's the same thing. So if we actually set them equal to one another, then we should be able to solve this, and we should be able to get something out of it. So in the top one, the coefficient of a is -1, minus a is just -1. In the bottom one, the coefficient of a is minus 7/10 x. Likewise, the coefficient of b is plus k in this one, and the coefficient of b is plus 3/10 x in this one. So we've got two equations. For the green one that I've written there, for a, we have got -1 is equal to minus 7/10 x. Now we can divide -1 by -7/10, which is the same as doing 1 multiplied by 10/7. Obviously just doing the reciprocal. Of course you can type that into your calculator. So you get x is equal to 10/7. So we've got something. We've got that value of x now. We know that x is 10/7. For b, if we look at what we had there, we have that k in the first one is equal to 3/10 x. Now that has two unknowns in it, so that doesn't really help us, but of course we've just worked out the value of x. We've just worked out that x is 10/7. So we now know that k is going to be equal to 3/10 multiplied by 10/7, the value of x. And if we work that out, you can type this in on your calculator, but that is 3 times 10 is 30 over 70, which is 3/7. We could have done some cross multiplying, cross cancelling there, but there we go. We get k is equal to 3/7. So now we know the value of k, we know the value of x, so actually we now have everything we need in order to figure out our vector. Now let's think about this. Now k was the letter that we used to say how much of b we wanted to go across in that first option. So in that option there, we thought about, okay, well we can get from O to n by doing some amount of b. And that's what we use the letter k for. And we've just figured out that k is equal to 3/7. So we have just said that this here would be 3/7 of the way across the line. That means that the other side of the line, this one over here, would have to be 4/7. So this one here is 4/7. So in terms of what we needed to do, we have actually found what we needed in terms of the ratio. We know that O to N and N to B, if we write this up here, O to N is 3/7 and N to B is 4/7. And if we times both of those by 7, we get the ratio 3/4. And that would be our final answer. So there we go. That there is the ratio 3/4, and that is our final question and the end of the paper. And that was some vectors with ratios. So there we go. Hopefully you found that useful and helpful. You may need to go through this question a couple of times because that is one of the really difficult vector questions that involves some ratios, and it involved 2 unknowns there. But there we go. Hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe. I'll see you for the next one.